So today we're gonna go over something that's called geometric. Well, it's still we're still in combo, but we're gonna apply like geometric skills for combo questions. So for this topic, I think we can go directly into just solving questions. Okay, so here's like a really common question that you might see. Okay, so two people, let's call them A and B. They're gonna arrive at a bus stop for 15 minutes. I cannot spell. Oh, so they stay for 15 minutes and then they leave. Yeah, 8% charged. I never use my iPad, so it's just dead. Okay, so they both arrive at the bus stop for 15 minutes and then they leave. And we know that they both arrive sometime, some random time from 7 to 8. Yeah, airplane mode saves battery, so I gotta do it. Or else like I'm gonna slowly get drained. Okay, so they both arrive at a random time at from 7 to 8. And then the question asks, what is their probability? They're gonna meet each other. So the first thing we notice is we have two different variables, A and B, and they can both arrive and leave at different times. So we want to find a way to represent both A and B with just like one representation. So what we're going to do is we're going to create an XY graph, or XY like plane, because that perfectly represents two different variables. So let's label this point 0, and then this is 60, because we know the time period is exactly 1 hour. So let's just like, so this is person A when they arrive, and this is person B. So we know they're gonna see each other if the time they arrive differ by less than 15 minutes. Because if person A, let's say if they arrive at like 7:10, and then person B arrives at 7:20, they're gonna see each other, because this time period is 10 minutes, which is less than 15. But like if A arrived at 7:10, but B arrived at like 7:40, they arrive 30 minutes apart, so they're not going to see each other. Okay, so let's just like plot a couple points and see what happens. So let's look at person A. If we plot the point right here at the origin, that means person A arrives at exactly 7 o'clock. So what are the different ranges that person B can arrive at and still satisfy that they're going to meet each other? So the person B must meet them within 15 minutes. Wait, actually, let's yeah. Okay, so person B can arrive anywhere from 15 minutes to 0 minutes, and it'll still be satisfied. And they're going to meet each other basically. And we realize that if person A arrives at any time, then person B can arrive from 15 minutes earlier or 15 minutes later. So basically, let's say, let's plot the point 30 minutes. That means person A arrives. Okay, let me just clear some stuff out. Okay. So let's say person A arrives at 7:30. So that means in order for them to see each other, person B must arrive in between 7:15 to 7:45. So like when we graph 30, we graph the ranges from 45 to 15. So that's the line of possible outcomes for person B. If we do this for every point, so for any point x in the x coordinate, we graph the values. We graph the values from y equals to x minus 15 to x plus 15. And basically, when we graph this, we're going to notice that it becomes like this kind of strip right here. Okay. So now basically all we have to do is we have to find the area of the strip. And we can do that by, there's a lot of different ways, but we can do this by finding the area of the white triangles, because these are easier to compute. So the white triangles represent when A and B do not see each other. And then the shaded region, this region, represents when they do see each other. So we want to calculate the area of the red region over total the area of the total square. So to find the area of the red region, we can just use the big square. The square has area of while each white triangle has the area of 45 times 45 over 2, because it's base times height over 2. But since there's 2 white triangles, there's 1 and 2, the total white triangles area is just 45 times 45. So now we calculate the area of the red region. So we're just going to do the total, the big square, subtracted by the 2 triangles, which is going to give us 3600 minus 45 times 45 is, let me see. I'm use a calculator because I'm bad at math. Okay, so that's going to give us 1575 is the area of this red strip. So now what we do is we just divide the area of the strip by the area of the total square, which is 3600. And then we get, let's see. Oh, we get 7/16 once we simplify everything. So this basically shows us that the probability of them two meeting is 7/16. Okay, so like this is like the most classic example of using geometry, but there's also like a lot of different examples. Here's like another one that appears a lot in like math counts and like AMCs and stuff. So two numbers X and Y are chosen randomly from the interval 0 to 1. So what this means is like X can be any number in between 0 and 1, like 0.4243, like 27. It can be anything. Shoot. And then similarly, Y can also be anything that they're randomly selected. And then the question basically asks, what's the probability X and Y are 1/2 away from each other? The question mark. So we basically approached this question the same exact way as the previous question. So what we want to do is, shoot. Okay. So what we want to do is we want to create another like two-way square kind of, but this time we label each axis from 0 to 1. And then we want to shade in the area such that X and Y are 1.5 away from each other. Okay, so we're going to approach this question the same exact way as the last question. So if you guys want to try and solve it, I'll give you guys a few minutes to try. Okay, so I'll go over the solution now. So it asks, what's the probability that X and Y are 1.5 away from each other? So we're just gonna, this is kind of hard to explain. So I might have not done a good job of explaining it last time. But basically, we just want to graph, or we want to shade the region such that our X value and our Y value are 1/2 away from each other. Oh, Justin. Yeah, Justin got it right. Good job. Yeah, I just saw that. Okay, so yeah, we want to shade the region such that X and Y are 1/2 away from each other. So for example, if x was 0, then y can be anywhere from 1/2 to 0. If x was like 1/4, then y can be from 3/4 to 0. So it'll cover this region. Similarly, if x was 1/2, then y can be any number. If x was, let me label these. If x was 3/4, then y can be anywhere from 1 to 1/4. If we do this for a lot of points, we're going to see it resembles this thing again. This kind of stripe. The thing with geometric probability is it's always going to form some kind of stripe. And we know that this point is exactly 1/2 and 1/2. So again, we just want to find the area of this region. We want to find the area of the red region, divided by a square, the area of the larger square. And we know the area of the larger square is just 1 squared, so the square area is just 1. And then the area of the white triangles, since this is 1/2 by 1/2, the area is exactly 1/8 for each of these. So the total area will be 1/4. And then therefore the area of the red is just 1 minus 1/4. I cannot write, which is 3/4. And then obviously 3/4 over 1 is just 3/4. So that's going to be the area. Wait, if I'm going too fast, you can put it in the chat, because if you don't understand like the thing I'm doing right now, I can try and explain it better. Okay. So like that's pretty much all geometric combination involved. Like sometimes they tell you like there's 3 numbers, and then it becomes like a 3D. Like instead of x and a y axis, you would need 3 different axes, which is more difficult, but it's still basically the same concepts. So like this is all the lesson we're gonna do today. So we're gonna move on to something else. 1 second. Let me just set it up first. Okay, so basically what I'm gonna do for the rest of class is we're gonna do a live solve of like a competition. So that's gonna be like where I solve questions, and then I'll like go through the thought process so you guys can learn like better problem solving skills, I guess. So let me just share my screen from my computer. Alrighty. So do you guys have a preference on like, I'm gonna do a AMC 8, so do you guys have any preference on what year you guys want to do? There's so many to choose from. Well, until it becomes something else. Oh, you want to do 2021? Wait, the 2021 is even out. We can only do 2019 to 2000 or 1999. So you guys want to do a 2012 or earlier? Okay, once I see a repeat, I'm going to choose that one in the chat. Okay. So 2011 it is, I guess. Okay. Now you guys can just choose a question now. I can do any of these, I think, hopefully. Oh, is the volume low? Oh, you guys all want 25? All right. Let me see if I can solve this one. Okay, so it says a circle with the radius 1 is inscribed with a square and circumscribed around another square is shown. Oh, which fraction is closest to the ratio of the circle's shaded area to the area in between the two squares? All right. Where's my draw? This is how you draw. Wait, how do you do this? I'm so confused. Wait. Oh, there you go. Okay, it's working. Okay. Thank you, Eddie. All right. So let's first mark up the information that they tell us. So they tell us the radius is 1 of this circle right here. So let's just label this line. Okay, so it's telling us that these lengths are 1. The drawing on a computer is so difficult. Oh yeah, I can. I don't know how to use this. Oh, wait. Oh, okay. All right, let me just restart. Whoa, that looks so much better. Okay, all right, thanks for that. So what it tells us is that all these radii are 1. Oh, you guys want time to solve it? Oh, I'm sorry. Okay. I'll give you guys like 2 or 3 minutes if you guys need it. Okay, did everyone have enough time to solve it? Are you guys ready for me to start? Okay, I don't think anyone said anything, so I'll just get ready to start then. So what we're gonna do is we're gonna find the area So the question wants us to find shaded divided by, like, we'll call this area the darker region and this one the lighter region, I guess. Let me see if I can erase this. Okay, so what this question wants us to do is find the darker region over the lighter region. I don't know why I'm typing in blue, but that's just what I'm going to use then. So first of all, let's just find the darker region first. So we realize that the darker region is just this big square subtracted by the circle. So the square has a side length of 2 because it's 1 plus 1 equals 2. So the area of the square is equal to 4. And then now we know that the area of this circle is going to be pi r squared. And since the radius is 1, it's just equal to pi. So the darker region is simply just 4 subtracted by pi. And then we're going to try and find the area of the lighter region. The lighter region is just the circle subtracted by the area of the smaller square. And what we realize is this area of the smaller square is exactly 1/2 the area of this larger square. So the smaller square, small square, is just, the area is equal to 2. And then the circle area is still pi. So what we realize is this region, the circular region, is pi minus 2. This is the lighter region. Okay, so what we want to do now is we're going to find the darker divided by the lighter region. So we can estimate oh wait, I'm being told I read this whole question wrong. Let me see. Wait, a circle and square. Oh wait, are both shaded area to the area between the two squares? Wait, what does that even mean? Oh wait, it's asking the ratio of the circle shaded region. Oh, okay. I'm reading this wrong. Okay, all right, my bad. So the circle shaded area is actually just the light region. And then the area between the two squares is like both the regions combined. Oops, my bad. So we're gonna just scratch that. How do you edit this? Okay. So instead, this question is asking for the light region divided by area between the squares, or total shaded. Yeah, I would have definitely got this one right. Got it wrong on the test. So the light region is just pi minus 2. And some of you guys, oh, what happened when you click edit? Yeah, it's a wiki, so you can like edit solutions and stuff. So basically pi equals 2. Some people might memorize, you have to memorize pi to be like approximately 3.14. So pi minus 2 is about, it's about 1.14. And the total shaded region is just the large square, this large square, subtracted by the smaller square. So it's just 2. So the question is asking light versus total shaded. So the light shading is going to have an area about 1.14, and then the total shaded is going to have an area of about 2. So 1.14 over 2 is just approximately 1/2, because it's approximately 1 over 2. All right. Hopefully I don't read the next question wrong. Okay, what question do you want me to do next? Okay, 24 factorial. That's pretty big. Okay, so I just do number 24 because it looks like a lot of people want it. So it says, in how many ways can 10,001 be written as a sum of 2 primes? Okay, so what we have to notice for this question is, let me move this here. We know that primes are always odd except for 2. So that's something we have to note. So wait, actually, what? Okay. Actually, I'll give you guys a hint. Yeah, this is my hint, and then you guys can try and solve it. I'll give you guys like a minute or 2. Okay, so I'm gonna start now. Oh, so first, for those of you who are not sure of what a prime means, a prime. Actually, I'll type this out because writing is difficult. So, prime is any number. Wait, is a number whose. How you spell who? This looks so weird. Whatever. Factors are 1 and itself. So, okay, so basically something like 70 is not prime, since we can write it as 35 times 2. But then something like 71 is prime, because you can't write it as anything else. And obviously, all even numbers except 2 are not prime, because you can divide 2 out of them. All right, so now we can start tackling this question. If it's a sum of 2 primes, and then if both of the primes are odd, then we will never reach this even number. So that means at least one of the primes is even. But we know that only even prime is 2. So it's 2 plus some other prime is equal to 1, 0, 0, 0, 1. And that just means P is equal to 9, 9, 9, 9. Okay, but we can obviously tell that this can be written as other stuff. It can be written as like 9 times 1, 1, 1, 1. So we know that this number is not prime. So that means this number cannot be written as the sum of 2 different primes. So our answer is going to be A again. Sorry, Aiden. I'm just making sure everyone knows how to do it. But if you want me to go faster, I can. All right, which question should I do next? Should I just go like backwards? All right, I'll just go backwards then, I guess. So the question reads, how many 4-digit positive integers have 4 different digits? The leading digit is not 0. The integer is a multiple of 5, and 5 is the largest digit. Okay, so there's so many different conditions here. So let's make sure we got all of them down. So you guys can try this while I type out the conditions. Okay, so I'll give you guys a few minutes to try this again. Okay. Have I given enough time for everyone? Okay. Okay, so it looks like a lot of people has finished, so I think I can start going over the solution now and how I would have solved this question. So first, we realize that there's 4 different digits. It's a 4-digit number because that's going to be our first condition. And then our second condition is that the first digit is not 0. So this one's not 0. And then we know that it's a multiple of 5. So what the multiple of 5 tells us is that this last digit has to be a 0 or a 5. So it's a 0 or 5. And then it tells us the 5 is the largest digit. So that means we can't have any 6s, 7s, 8s, or 9s. So the only possible digits that we can use are 0, 1, all the way to 5. So what I'd like to do first is we're going to start from the most restrictive condition. So the most constrictive condition is on a restrictive condition is going to be on our units digit, since it can be only 2 different digits. And then now we're going to proceed by casework. So basically what that is we're going to do like case, let me scroll first. Oh shoot, this thing moves with it. I did not know that. Okay, so we're going to go with, I'll do my work on this side. So our case 1 is that units digit is a 0. So the last digit is a 0. So now we're left with the digits 1, 2, 3, 4, and 5. For the first 3 digits. And then we have to make sure they're all different. So basically for the first digit, we can have any one of these 5 numbers since they're not 0. So what we have right here is those 3 and a 0. So for this digit, we can have 5 different choices because it can be any one of 1 to 5. But for the second digit, we only have 4 choices now. And we only have 4 choices because we can only choose, we can't choose the one we chose in the first digit, or else because we need all the digits to be different. And then for the third digit, we have 3 different choices because it can't be the same as the first 2. So there's only 3 different ways. So if we multiply all these up, we get there's 60 different things for this case. Okay, and then we go to the case 2. Is when the units digit is 5. So that means we have an integer that's something like blank, 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 5. And then now we have the integers to choose from. We have 1, 2, 3. Oh, we have 0, 1, 2, and 4. Oh, wait, shoot. I realized I messed up on the first case. Oh, wait. Okay, I read the conditions wrong, actually. So one of these conditions is 5 is the largest digit. So we know that one of these has to be 5. I thought all digits were just smaller than 5. So we need at least 1 5 for this case. So we have 3 ways to put the 5 in, because we can put the 5 here, we can put the 5 here, or we can put the 5 here. Let's just ignore this for a second. So we have 3 ways to put the 5. And after we put in the 5, we can get rid of this choice here. So we have 4 choices for the other digit. So let's just say we put the 5 here. That's a random placement. So we have 2 other spots left open, here and here. We have 4 choices for this choice, because we can choose 1 through 4. And then we have 3 choices for this choice. because it can't be the same as this one. So in this case, we actually have 36. Sorry if my handwriting is like really sloppy. And then for this case, where the unit digit is 5, these three can be, so this one cannot be 0. We already determined that. So this one can be 1, 2, 3, or 4. So there's 4 possibilities for this case. And then for this case, we get rid of one of these numbers. So let's just say we put like, this is random, so it doesn't matter. If we put the 4 here, then we don't have the 4 anymore. But then we get the 0 back. So we have 4 more ways for the second choice, for the second unit. And then for the third digit, we have 3 choices because we can't choose the same one as the previous 2. So this one's going to be 48. And we realize that these are the only 2 cases of the question. So we can just add these 2 up and get 36 plus 48. This is hard math, 1484. So it's going to be D. Okay, should I just keep going back? Or do you guys want to do like something else, like a different question? People are saying like 1 and 2. 1, 2, 3. Okay, all right, whatever. Majority rules, I guess. I guess we can just like, we learn how to do these questions fast. We'll just like speed run these. So I'll give you guys like 20 seconds for this one. And you guys should get the answer. All right, yeah, this one's pretty easy. We just do 5 minus 3 times 0.5, and we get E. All right, we should be getting that one pretty fast. Okay, number 2. I give you guys like 20 more seconds. Okay, yeah, this one's also pretty easy because 25 times 40 is 1,000. The other one, when you multiply them, it's 900. So it's E again. I think these questions are too easy for you guys, but like, should I keep on going? You guys want to do MC? Wait, Eddie, stop trolling. Okay, I guess we can finish with MC if you guys want. Wait, I haven't been here in so long. It's at resources, right? Past competitions. I haven't gotten math counts for so long. Okay, we'll do some state then. All right. Which one do you guys want to do? Which question? 1 to 30. Do you guys want to start at the back? 45. I don't know. I think we only have time to do like one or two more questions. So choose wisely. Wait, is there baby in the background? I'm not sure. I don't think I'm causing it. I don't know though. Oh, that alarm, that might be my like security system. I'm not sure. That thing beeps a lot. But there's so many different random numbers. I don't know which one to do over. Wait, 30 is actually like a really hard question. So like I probably can't explain that one in like under 5 minutes. Oh, well, RNG says 26. So that's on the later end, so we can do that one. Okay, whatever. Let's just do number 26. Let's see if my shape using is better. Okay, so let's just draw the coordinate first, the coordinate system. So it says a circle is tangent to the positive x-axis at x is equal to 3. So let's just draw a circle. Whoa, this looks cool. Shoot, wait, let me redo that. Wait, I'm so bad at using this. All right. So they're telling us that it's tangent to the positive x-axis at x equals 3. Wait, where's the button? Okay. So it's telling us that this distance is 3, x equals 3. And then it's telling us that it passes through the distinct points 6, 6 and p, p. So like if we draw this line of x equals y, it passes through 6, 6. And then it also passes through p, p. Let's just draw these lines to look good. Oh wait, I forgot I have a line drawing. That's gonna be useful. Dang, I should have used that a long time ago. All right, so something like that. Okay, so what we want to do is we want to realize that there's a pair of similar triangles here. I'm not sure if we covered this in our geometry lessons because this one might be a little bit hard. But basically, it's a pair of similar triangles here. There's a couple of theorems that say this angle right here, since it's tangent to a circle, is also equal to this angle. Actually, let's label some of the points first. So I'm specific. So let's call this point A. A is the origin right here. The tangent point is going to be B. This P, P is going to be called C, and 6, 6 is going to be called D. So there's like a well-known theorem. It's called the tangent theorem. I don't know the exact name, but it basically says this angle is equal to this angle, or angle. You guys should learn this in school, I think. It should be taught when you guys learn geometry in school. So it's going to be ABC is equal to angle ADB. And then we know that obviously, angle CAB is equal to angle DAB because they're just the same angle. Like if we look at it, they're just the same exact angle. Okay, so if we know that two angles of the same triangle are congruent, we know that they're similar. So we have that the triangle of ABC is similar to triangle ADB. If you're wondering when you learn this, you learn it when you take geometry in school. I'm not sure, but like in Florida, we learn it in about like 8th grade, I think, 7th or 8th grade. So ABC is equal to ADB. Well, they're similar. So we know that there's ratios. So we know that the length AC divided by AB is going to be equal to AB over AD. And we get these from the similar triangle ratios. So we know that the length of AB is just 3, because that's given us in the question. Oh, we can, let's just multiply each side, and then we can make this AC times AD equals to AB squared. And you might learn this later, it's called power of a point, but you guys don't need to know that. We just plug in the distances now, because we know that AB, that distance is 3. And then we know that AD is 6, 6. So that distance is going to be 6 square root of 2. So now we know that AC is just equal to 9 divided by 6 square root of 2. Which is just equal to, let me see, 9 square root of 2 over 12. 3 square root of 2 over 4, I think. And since this is also equal to P times the square root of 2, we can divide both sides by the square root of 2, and then we'll get P is equal to 3 over 4. And if I didn't make a mistake, that should be our answer. Let me just double check my work here. 3 over 2 square root 2. Okay, yeah, that should be our answer. Oh, so we're a little bit past 9, so, or 6, wherever you guys live. So that's gonna be it today.